Hello, everyone, and welcome to another Jakarta Tech Talk. Joining us today, we have Reza Reham to present on applied domain-driven design blueprints for Jakarta EE. Reza plays a large role in the Java and Jakarta EE industry. Reza is a former longtime independent consultant, enterprise architect, and Java EE evangelist at Oracle, and is now a principal manager for Java on Azure at Microsoft. If you have any questions for Reza as we move through the presentation today, feel free to ask it in the chat or using the Ask a Questions tab at the bottom. And without any further delay, Reza, over to you.
Okay, so wherever you are, good morning, good afternoon, good evening, maybe, depending on if you're in the Asia Pacific region or not. So this is applied domain-driven design blueprints for Jakarta EE. There's a couple of different ways I can actually do this talk, but principally, this talk is about how Jakarta EE aligns with um, basically popular design patterns and design paradigms like domain-driven design. So in my day job, yes, I'm principal program manager for Java on Azure, but actually this particular talk doesn't have much to do with my day job. Principally, I'm presenting today mostly as a Jakarta EE ambassador. Hopefully you can go find out a bit more about what the Jakarta EE ambassadors are. On screen, of course, is all of my contact information. Also, not that hard to get a hold of. So if you have questions on any of this, in fact, if you want to get involved in Cargo Tracker, or maybe even consider doing this particular talk in your company or Java user group, I'd be more than happy to help you with all of that. So there's a couple of different ways we can go about doing this talk. I want to make sure to explain the motivation for this talk a little bit, and then have a little bit of a dialogue with you guys to see how best we can take advantage of the hour or so that we have in our hands. So I think we all are probably mostly familiar with the so-called J2E blueprints or Java Pet Store. So I certainly remember it, and I also remember the chaotic days of the early server-side Java development back in the 90s. So what happened was, it was honestly complete chaos. Like every single project would have its own design paradigms. None of the projects would look very similar at all. If you're lucky, there'll be some kind of architecture. In many cases, it's like embedded code written in JSPs and the like. So it was honestly not a very maintainable situation. So we needed to get some kind of structure around that. And the answer to that back in the day from Sun was this thing called J2E blueprints or Java Pet Store. And what they basically did was they said, okay, we need well understood architecture paradigms to design these server side applications. And believe it or not, that project has had really a profound positive impact on our industry. Even today, when we talk about many of these design patterns, a lot of these design patterns have either originated back in that Java Pet Store or J2E Blueprints project, or they took stuff that was in books like Gang of Four design patterns and applied them to server-side Java and showed you really how to do that. So even today, if we are using things like DTOs and factories and DAOs or facades or anything else like that, chances are really what you're really doing is implementing those very ideas that were first shown in action and put into the mainstream by the Java Pet Store or J2E blueprints. Now, the reality is that the J2E blueprints had its own problems. As such, it was not a problem of the project itself as much as it's the immaturity of the technology. So back then it was EJB2 entity beans and session beans and maybe even not that. And as you know, all of those technology sets had limitations, right? Understandably, it's very early days of server-side Java development. So all of those things, transposed into the Java Pet Store, all of the things that are weaknesses in the technology set ultimately surfaced as either design patterns to work around it or limitations in the architecture. So the answer to those problems, as we all know, ultimately was Spring and Pojo-based programming and Hibernate as opposed to entity managers, and obviously from the Java EE side, instead came annotations instead of XML. early version of that was Xdoclet. I still remember using Xdoclet with J2EE. So basically, as the industry matured, we realized, okay, there's all these weaknesses that's stopping us, in particular, from taking advantage of object orientation in the way that we should in a Java environment. So then came the rise, and frankly, the same thing was even happening in the .NET space as well. They had some of the same problems and were going through the same set of evolutions. So through these sets of evolutions came in a new architecture paradigm at the time, and this has frankly been almost 10 years now. Domain-driven design is definitely not new anymore, and this is why I'll ask you the question in a moment. And this brought rise to this new architecture paradigm called domain-driven design. This really actually not that new when you really begin to look at it. Basically, what they did was they took server-side Java development. They took the concepts that are coming out of the Java Pet Store and the J2E blueprints and adapted them to object-oriented design and analysis. Right. So you come up with slightly different semantics, a slightly different set of design patterns, but really a radically different way of thinking, as opposed to what was possible using J2E and the J2E blueprints and Java Pet Store. And we'll see some of those differences in a moment if you don't know what I mean. But the reality, though, for me was that for Java E5 onward, right, you basically could apply domain-driven design perfectly well, in fact, quite well, using Java EE and now Jakarta EE technologies. So I thought, okay, this is obvious to me, but it doesn't seem to be obvious to a lot of other folks. What can I do to better educate folks? So I thought, at that point in time, I was working for Oracle. So I thought, here's what I'll do. I'll just create a new version of what the uh, J2E blueprints or Java Pet Store was supposed to do. And instead of applying these J2E design pattern uh, specific paradigms, I'll simply apply domain-driven design because I can see and I know and I've implemented domain-driven design well enough in Jakarta EE, and it fits very well. So that is how the Cargo Tracker project came out to be. So it was supposed to be, frankly speaking, a replacement to the Java Pet Store, showing you this new and better design paradigm and design patterns on how to apply them using Jakarta EE. So it was part of the official blueprints for Java EE. So as you all know, the whole thing moved to the Eclipse Foundation. So with that, I also helped move the Cargo Tracker project back into the Eclipse Foundation as well. Not obviously as a spec project because this is not a spec, but basically as a part of the Jakarta EE umbrella. So this is part of the EE4J project set of projects, and basically it's one of these projects that sort of goes hand in hand with the Jakarta EE specification and platform and implementation projects and the like. So that's a bit of, so basically what we'll do today is give you an introduction of Cargo Tracker in a manner of speaking, right? So when I go to do this presentation, what I often find is people actually, even 10 years on now, a lot of people actually don't really understand what domain-driven design is. And that's where I need to I find myself starting with this presentation instead of focusing more on how to map domain-driven design concepts into Jakarta EE. So it's a delicate balance that I always, wind up encountering when I'm doing this talk. And in fact, even explaining even demonstrating Cargo Tracker, I often run into the same issue, is that you can't really even assume that people know or even understand domain-driven design, let alone how to apply it in Jakarta EE. So that's where I tend to start in this talk. But there have been situations where I have encountered people that say, yeah, I know domain-driven design. I've read the book by Eric Evans, and I've done some research on my own. All I really need to know is, hey, how do I apply this in a Jakarta EE environment? Show me the actual implementation. No need to explain the actual concepts behind domain-driven design. So that is sort of a forking point of how I can approach this talk. right? So we can skip over the domain-driven design introduction. But if we do not, then I will actually need to spend at least half or more of my time today explaining what domain-driven design is and explaining some of the fundamental design patterns in domain-driven design. So before we start, I'd like to do two things. Number one, I'd like to tell you there's no need to hold questions until the very end. I try to keep this talk, in fact, I hope all of my talks fairly conversational. So if you have questions, just ask them. So there's a couple of different ways you can do that. On Crowdcast, simplest way is just enter your question in the chat, and I'll intermittently check. There'll be natural pause points during the talk where I can do that, and I can check to see what questions you have, and I can answer your questions. Or you can use this little Q&A function that's also in Crowdcast. I think it's a little bit more kludgy to use, but you can feel free to use that also. And again, I'll check that and answer your questions as we go. So that's number one. Number two is I really would like your help to help you to best understand how I can help you today. So as I said, there's a couple of different approaches of taking this talk. So here's what I would like you to do. In the chat, if you would like me to start with an explanation of DDD before we jump into Cargo Tracker, just type in DDD. If you would like me to skip the DDD portion and focus more on how DDD applies to Jakarta EE, just type in Jakarta EE. So I'll give you guys a few minutes to think about it. Please do me a favor and do type in your preference of how we can approach the next hour or so, 50 minutes or so, actually 45 minutes or so now. So yeah, please go ahead and do that, and then I will sort of tailor the talk accordingly. Okay, I see 50 some people, folks. Please type in your preference. Focus more on Jakarta EE or focus more on DDD. I'm going to give you just about a minute or more. No more than that, okay? So if you don't have preference, it's fine. But if you do, make sure you let me know what that preference is. So folks, it's an even split now. So if anybody wants to put in a tiebreaker vote, please do that. Nobody for a tiebreaker? All right, I think we have a tiebreaker. So I think let's stop there. As it turns out, almost always in this talk, people don't really know DDD that well. However, it's a close tie. So here's what I'm going to do. I'll spend some time on DDD, but not too much. I'll try to limit my time of the explanation of DDD, not to lose the people that are already familiar with DDD. But I hope it's an okay investment for you guys that already know DDD, because it's always useful in terms of these architectural things to get somebody else's take on what is the thing, and sort of have a refresher in your mind as well. So we'll explain DDD a bit. And then we'll move on to, as quickly as we can, to the Jakarta EE mapping portion of the talk. Okay, so what is DDD exactly? I've sort of given away the explanation of that a bit. So DDD really is nothing much more. The expansion of it is domain-driven design. So the idea here is that your implementation and your application should look like the real-world thing that you're trying to implement. Whether it's a database field or name of a table or name of a schema or name of objects in your software, screen names, URLs, so on. all of these things should map to things that are there in the real world. In fact, the idealized view of domain-driven design is that if you were to, go over your architecture design diagram or UML diagram or database schema with somebody in the business, they ought to be able to understand what the thing is. So the names should be very similar, and in general, things should attempt to model the way the actual business domain that you're trying to accomplish. And the reason this matters, it goes back to that fact that we can actually do this and do this very well in Java, right? In fact, this is the whole reason why object-oriented development and analysis came about in the first place, is to be able to model things in that way, right? So in the real world, things are nouns and verbs, and things have relationships and behavior and internal state and so on. And that is fundamentally why why people came about with the idea, why you had the transition from C to C++, and why you needed to sort of introduce this concept of object orientation. So that is a fundamental philosophy behind domain-driven design. Sometimes it's called the ubiquitous language. So in other words, whatever language you are using to express yourself in code should model the language that you are using when you are discussing things with your business analysts or even your end users, if you will. So with that view in mind, what happens is, what comes out of that is certain design patterns. The same as is the case with the J2E design patterns or Gang of 4 design patterns. What comes out of that, other than a philosophy and an end objective of what you're trying to do, is these common things, common patterns that you ought to apply in your applications. So this is in order to explain this, what I'll do is I'll simply take one of these well-known diagrams that are out there. I won't invent anything because there is no need to. That was actually part of the reason why I decided to do Cargo Tracker, is just to simply leverage the knowledge that is already out there in the domain-driven design field and simply reference it. Right. So I'll do the same thing here. So this is a well-known diagram that basically explains to you what the fundamental building blocks are. Another way of looking at this is what are the key design patterns in domain-driven design. So we'll talk a little bit about what these are. So let's start with entities. Entities are probably the most important design pattern in domain-driven design, and it's the heart of basically object-oriented analysis. An entity is a thing. It'll be a noun in the real world. An entity has a few things. It has certainly a unique identity. It's uniquely identifiable. If you want to think about it in terms of relational databases, it's basically the ID, the unique ID for a row in your table, if you will. And in the object-oriented world, it'll have a field called an ID that is unique to that object. The other thing that entities have is internal state. We think of it as data, basically. Fields, in, either private or public fields. This is the internal state. And every single thing in the real world actually has internal state. We have internal states. And every single machine or thing or process, they all have internal states, data that represents what they are. Entities also have behavior, and that is fundamentally different from the old way of doing things in the J2E design patterns world. So things do things in the real world, and you model these as methods that ultimately have logic as well as behavior to change the internal state of itself. So that is basically the methods and the fields of an object. That is what an entity is supposed to be, and you'll have many of these in your domain model. This will be probably the most common thing you'll have within your domain model. The next design pattern in DDD is value objects. So value objects and entities are very closely related. They are both things or nouns in the real world. They both hold both internal state as well as behavior, so fields and methods. The difference between entities and value objects is that value objects do not have identity of their own, right? They sort of think about it as sort of helper things that are attached to other things. And this actually reflects the fact that in the real world, things are related to each other. They reference each other. And basically, entities and value objects often it has a relationship, so containing relationship. So a good example of an entity would be an employee, let's say, right? So whereas a value object, a good example of that would be an address. An address doesn't necessarily need to have an ID, have an identity of its own. It's simply there to be able to model your data better, right? So each employee will have an address, and that address object is, nested within your employee object, so it doesn't need an ID on its own. So next concept to understand in DDD is aggregates, and again, it goes back to the fact that things in the real world are related to each other. And often what happens is there is a hierarchy of relationships. So some objects are actually more important than others. Some nouns are more important than others, particularly when it comes to domain-driven design or domain modeling. So if you're designing a bank, you can imagine probably one of the most important entities would be an account. Okay, another one would probably be a customer. And then you'll have a bunch of other entities that are interrelated, right? Interest, balance, um, debit card. So these will be all objects. But ultimately, when you go to model these objects, some objects are going to be more important than others. And in fact, what we also observe is that in these relationships, there are sort of these clusters of relationships, right? So you have these top level important entities that are interrelated to a lesser set of important entities, and there's a few of these, right? So there's a number of these here and there. So again, another example would be in the insurance domain. The insured and the policy would probably be, if you will, important entities, and then there'll be a bunch of stuff interrelated to those particular sub-entities, if you will. So this is what's known as an aggregate. Okay, so in particular, particular entities will also be called aggregate roots for this reason. The entities that are really, really important in a particular domain. Next is repositories. So again, when you're talking about systems, as we all know, systems mostly consist of disk and memory and CPU, right? So basically, when you are materializing a system and it is running, it'll be mostly consuming memory and CPU. But the other thing is it also needs to be persistent, right? So all of this data that you have that's modeling the real world ultimately needs to reside in some place that, if you shut down the computer or restart it, that data is going to come back up. Of course, we all know this as a database. Or it could be simply a file system storage, some kind of storage. So you need some kind of mechanism that will take this nice domain model that you've created and persist it somehow. And this is the purpose of the so-called repository. So this is the other design pattern that is very, very important, and this is also part of essentially a part and parcel of your domain model. This thing called repositories, and repositories, unlike DAOs, actually relate to the aggregate root, whereas in a DAO world, you will tend to have DAOs per, if you will, quote unquote, entity, whereas in domain-driven design, you will have lesser number of these. So lesser number of repositories and largely corresponding to the aggregate roots, and we'll see why in a moment when we begin to dig into the code. Next one is a familiar one from Gang of Four design patterns called factories. So for the most part, when you're constructing these objects, your object model in the application, you can mostly get away with just invoking new a few times and then calling a bunch of setters, and you're good to go. But in some cases, though, it's not as simple as that, right? So if you're going to create an aggregate, and in the creation process itself, there is business logic, and it seems to be relatively non-trivial. The way you abstract the creation process of those objects or entities in the system is to basically create this object called a factory, and whose job principally is just to help create these complex objects. So this is a Gang of Four design pattern that, by the way, also exists in J2E design patterns, and is basically imported into the domain-driven design world. There's also services, and services are a little bit tricky because and this is because maybe they could have found a better name for it. So services is not RESTful services or SOAP services or anything else like that in this context. So those things in the domain-driven design world is actually part of the interface layer, and we'll talk about that in a moment. This is what's called domain services. So not everything in the real world is actually a thing. Sometimes verbs are important enough. So again, taking a look at an example of a bank, a transfer is actually not necessarily a verb, right? So it's more, sorry, not necessarily a noun. It's more of a verb. Same thing in the insurance domain. There's something called underwriting. Okay, this is actually a process. It's more of a verb than a thing. Similarly, in logistics, one thing that probably is very, very important is scheduling. So these are basically verbs that are important enough to be modeled outside of entities, sort of as top level parts of the domain. And this is what we mean by domain services. And domain services typically will be just a single thing, right? It's a complex enough business object that warrants its own top level Java object, and it won't have much state per se. What it will have is fairly complex business logic, and it will basically manipulate the state of other entities. So this is what a domain service is, and we'll take a look at a domain service, in our application as well. So aside from that, there's a bunch of other concepts, layered architecture, which we'll talk about in a moment, and of course, domain modeling or object-oriented analysis is driving all of this stuff. And this can be either upfront design or more typically, it's evolutionary design. So you'll come up with some ideas as you are implementing it, and then you'll refine them as you go. Okay, so next I'm going to be talking about layering and separation of concerns. So there is a few design patterns that come into play while thinking about this as well. And actually, most of these are fairly similar to what you may be used to from J2E design patterns world or otherwise. So before I jump into this, let me pause a little bit and give you just a minute to think about any questions that you might want to ask. If not, we will continue moving forward here. Okay, any questions so far? Nope, I'm going to assume no. Okay, all right, well, if you do come up with questions, you can ask them a bit later. It's not a big deal. And also you can ask me later on as well. Okay, so when you are talking about designing these applications, you have your nice domain model, but you actually need something a bit more than that. And what you need is a way of separating concerns. I'll explain why. So let's assume for a second that all you had is this domain model with the design patterns that I talked about before, and that is the heart of domain-driven design, if you will. What will tend to happen is that you will get really bloated entities for the most part. The reason is that you'll find that you're adding more and more functionality that's not related to business logic per se, and not even related to the domain. All this you are really doing is adding stuff to deal with infrastructure concerns, so deal with implementation concerns of the system. And I have seen such things, specifically in the early days of domain-driven design. I've seen these sorts of things where people have this real resistance to adding this other concept called layering and separation of concerns, and as a result, they wind up with these huge entities, and then they are, if you will, become a new version of that jumbled code inside of JSPs, if you will. So the way you solve this problem is the same way that we've solved the JSP problem, namely separating the presentation concerns from the Java concerns. And in most server-side applications, these concerns are actually relatively common. Right? They don't differ very, very much. So this is why you should really consider, in addition to doing domain-driven design, considering also this optional part of domain-driven design, and that is layering. Okay, so in server-side applications, there tend to be these layers, right? And they're relatively prescriptive. So first and foremost, you have the interface layer, and this has to do with I/O essentially, or user input output, or UX, in other words. So there'll be things like your web application framework or your JavaScript fancy JavaScript framework, your REST interfaces that talk to that fancy JavaScript framework, maybe system to system communication interfaces like batch. For example, these all belong in the so-called interface layer. So you should have objects that are dedicated to concerns of the interface layer. That's the idea here. Next level down is the application layer, and this basically has echoes of how we used to do things in the J2E blueprints way of doing things. So these are basically objects that model high-level use cases in your application. So these are mostly verbs, actually. So this is a high-level object that maps to, if you will, a subsystem, right, in your application that has these behaviors that are very, very coarse-grained. Each of these behaviors will be invoking multiple domain objects, potentially domain services, entities, value objects, and making them actually work in a sort of long script, if you will. So this is what is known as you can think of this as a facade. If you're familiar with the business facade architecture blueprint from the J2E days, this is the same thing here. So this is an abstraction over a high-level use case in your application, and you'll have smaller numbers of these, smaller number of these application services, if you will, in your application. The next level down is, of course, the domain, and that's all those things that we talked about before: entities, value objects, factories, repository. These all belong in the domain layer, and this is going to be the heart of your application. The idea here is that you can throw away the application tier, you can have different application tiers altogether, you can throw away the interface layer altogether, but the core of your application still remains basically static in your domain model, and encapsulates how your real world modeling of your application should really look like. Aside from this, we have this cross-cutting layer called the interface layer, rather the infrastructure layer. And the infrastructure layer is basically anything to do purely with application framework concerns and system implementation concerns. In fact, this is where Java EE really shines, because a lot of these so-called infrastructure concerns actually are baked into the platform itself through, in many cases, declarative annotation. So all you need to do in order to add a bit of infrastructure is just take your application domain or interface layer concern and just add an annotation to it. And lo and behold, what's happening is you're getting a bunch of infrastructure services without really realizing them. So the infrastructure layer can actually be used by any of these layers. It's not a distinct layer on its own. These are distinct parts of the application. So you will, if there's something that you are implementing that is clearly infrastructure, it will belong in that infrastructure segment, and it's in its own specialized object, if you will. But they can be consumed by any parts of the any layer whatsoever. Typically, infrastructure will tend to be consumed at the application layer, but it can also be used by the domain layer. In particular, I prefer to follow the paradigm of separating the repository interface and make the repository interface part of the domain layer, and the actual repository implementation being part of the infrastructure layer. So separating the interface from the implementation and separating in the layers that way, and basically creating a little bit higher of an abstraction layer to Okay, so looks like we're back. If we're not back, please let me know in the chat if you're having any issues. I'm going to start sharing my screen again because I assume my screen share was probably lost in the process. Okay, do let me know if you're all set. And I'm going to basically restart back where we stopped, and that is beginning to map DDD concepts into Jakarta EE. So here's a little diagram. The diagram actually is on the website as well as the documentation and cargo tracker, so you can reference this later. And by the way, this slide deck is also available on Speaker Deck. You can just Google it and you'll find it. So this is all there for your reference. So let's start top down, if you will. So let's start with the interface layer. So interface layer, basically the things like JSF, so any JSF backing beans, REST, in terms of any REST interfaces, things that you apply the JAX-RS annotations to. Similarly for WebSocket and batch. So if you're implementing Java batch and you have these artifacts like readers, writers, and operators, these are actually part of the interface layer. So they should be objects on their own, and they should be specialized to doing basically just what they're doing in terms of implementing those parts of those technologies specifically. Similarly, the application tier objects typically will be implemented either using EJB or enterprise beans or CDI. And enterprise beans in particular is a very good fit for the application tier, and we'll see an example of why that is. Basically, these application services, the methods in there, tend to model units of work or use cases in the application. So it is a perfect place to serve as transaction boundaries, or where you apply declarative role-based security, or potentially where you would want to apply asynchrony. So that is why it actually makes a lot of sense to implement these application tier objects using enterprise beans or CDI. Right, so you can use CDI and apply the transactional annotation and hopefully even more EJB-like services going forward. So that is something where that's how that layer will typically be implemented, at least in Jakarta EE. For entities, usually there's a very clean mapping, frankly speaking. There's no need to really overthink this too much. Basically, entities, for the most part, map directly into JPA entities in Jakarta EE-based systems. Value objects are a little bit more complicated. So in 80 to 90% of the cases, you will be implementing value objects as embeddables in Jakarta EE or Jakarta persistence. There will be some edge cases where something doesn't really need an identity, but you need to kind of give it a synthetic identity. So it's a value object, but it winds up being implemented as an entity in Jakarta EE. It's a rare error case. In most cases, you will there's a direct mapping between embeddable and value objects. In fact, it would be awesome if Jakarta persistence just named the thing value objects following the domain-driven design patterns, but that's not the case. Infrastructure is actually a lot of Jakarta EE belongs in the infrastructure layer in one way or the other. So things like implementations of the entity manager interface, where you're using that, it should probably just be its own separate object that does that. Same thing for JMS, REST client, Java Mail. All of these sort of belong in their own objects in the infrastructure layer typically. Repositories, again, fairly straightforward in most cases. They'll either be implementing that using the JPA entity manager, or if you're using NoSQL or Jakarta NoSQL, that has its own repository implementation, literally baked into the technology, and it's called add repository. So it's telling you, hey, this is the same thing as a DDD repository concept. So definitely, there's analogs to that. That will be what your repository implementations will typically be. So either the entity manager portion of JPA, or the corresponding thing in the Jakarta NoSQL. And you'll typically be making use of some CDI here just for dependency injection. Okay. I'm going to skip over bounded context in the interest of time because we don't have that much time left. So I'm skipping this over. So here's the thing that is there in the Eclipse Foundation, and the thing that will show you how to put all of these different concepts into action. And in fact, some of what I talked about, a basic introduction of DDD, a basic introduction of how you go about mapping DDD into Jakarta EE, some example implementations. All of this was actually part of the documentation of the cargo tracker project. So you can take a look at all of that aside from the talk today. But the main project is in this URL. I'll go over to that URL in a moment. And first thing I'll do is I'll just show you the application so that you're familiar with what the application is. By the way, there's also a video explaining the core concepts of or the main parts of the main functional parts of the application as well. So I won't repeat too much of that. I'll just give you a small taste of the project. So let's go over to the browser. And here is the main cargo tracker website. Okay, so in the cargo tracker website, you'll see the overview, the stuff that we went over. There'll be goals and non-goals listed for you. And here's how you get started. It's super simple to get started. I actually have the application running locally. You can just use. You don't even need to use an IDE if you don't want to. You can just run it through Maven. It's using Pyara today, but technically we have plans to, as time permits, to apply it make it run on all of the major Jakarta EE application servers. And of course, there's a GitHub repo with all of the source code as well, aside from this website. So yeah, all you need to do in order to run it is just run this guy and make sure you have Maven set up correctly, and you're good to go. You can begin to get started with the application. In fact, it's even easier because we have the application running using a Kubernetes implementation on the cloud in publicly also, right? So I'll go ahead and open this guy. Okay, so this is the application running locally. I won't actually be using that today in the interest of time. We can just do the cloud demo actually. So here's the application running on the cloud. You can access it through this URL. It's again running on a Kubernetes cluster. Thanks to our friends at Gelastic, they're hosting the project on their cloud very kindly. So we'll use that for the demo, and you can do the same. So here's explaining the background that I just did. The Jakarta EE to DDD mappings that is also explained here. Okay, and we also have the goal of this project is not to add every single Jakarta EE feature that you can think of, right? So it basically has a representative set of what you would encounter in most quote-unquote monolithic applications or cohesive applications. So we do have a decent amount of stuff that we use from Jakarta EE. If you're curious about that, you can take a look at this table and it'll tell you all of the different things that we use out of Jakarta EE actually. So you can see that we're using quite a few specs, not all of them, but quite a decent bit of the specs are actually in use in the application. Okay, so let's go ahead and do a quick demo of the application. So there are a few different interfaces to the application. So the application, what it does, as the name implies, is basically track cargo going across the globe. So it's supposed to be modeling a shipping company's interface, basically. So the first is a public tracking interface. And basically you can, if you know your tracking ID, right, you can enter your tracking ID and you can see where your cargo currently is. So as you can see, ABC123 is currently in Helsinki. We don't have estimated time of arrival yet. So here's the handling history. It's received in Hong Kong, loaded onto a voyage, and received in Gothenburg currently. So you can also see a mapping of the destination, the last known location, which is Gothenburg, and the origin, which is Hong Kong. Okay, so and you can take a look at some other ones here as well. So let's take a look at another one, JKL 567. Okay, so it's currently misdirected. We don't know when it's going to arrive in Stockholm, and it's currently on board a voyage. All right, so going back, there's also an administrative interface. So over here, you can see all of the, where all of your cargo is in one go. In fact, there's also a live map to show you the same information. So you can take a look at where all the cargo is currently and some information about the cargo. You can also route a particular cargo. So if its cargo is not routed, you can say, hey, go ahead and route this. And it'll give you a few routing options. Right? So you can pick a routing option and then it'll be routed. Okay, so this is the, if you click on one of these, it'll tell you what the route is supposed to be. You can also book a cargo, right? You can say, let's say, okay, going from Hangzhou to, let's say, Rotterdam. Come on. Okay, and let's say you want to arrive in February, so on. So you can go ahead and book a cargo, and basically here's your new cargo that was just routed from Hangzhou to Rotterdam. So there's also a mobile event logging interface. Okay. That's not really supposed to happen. This is supposed to open in its own window, so I'll need to look at what is going on there. But okay, so you can take a tracking ID and say, hey, I want a location on it. And there's several different things you can do to cargo. So you can receive, load, unload, claim, and so on. Right? So these are the different things you can do to any bit of cargo. Okay. So that is, I think, enough of a demo of the application. And now let's move on to the code itself. So let me close this window. I don't think we need it anymore. Okay, so now we can, I think, begin to dig into the source code and see how the source code looks like. And I'll do that using GitHub. I think I could pull up the IDE to do that, but there's no real reason to actually. GitHub does a pretty decent job of color coding things and so on. So here's all the code. So let's begin to see how these DDD concepts are applied in the cargo tracker application. So let's go take a look at main and take a look at the Java source code. There's a couple of different modules to this application. There's also actually a different thing that could be spun out in its own microservice called Pathfinder. But most of the code is actually in cargo tracker. So as you can see at the top level here, this is a breakdown of the layers, layering concepts that we talked about already. So you have the application layer, the domain layer, the infrastructure layer, and the infrastructure layer. So we'll start. I think top. Let's start from the top. So here's the infrastructure layer. Okay, and as you can see, there's a couple of different interfaces. Sorry, I meant to show you the interface layer. Apologies. So there's a couple of different interfaces that we talked about before. Right? There's a booking, handling, and tracking. So if you take a look at, for example, the tracking interface, here is the track object, and this is basically a JSF bean, and it's part of the infrastructure tier. So this just deals with infrastructure concerns, right? So it has a view adapter, and it does things like handling what happens when somebody says, "Hey, give me that where a object is supposed to a cargo is supposed to be tracked and so on." Right. So, and this basically interfaces with the rest of the domain, in particular with the cargo and cargo repository interfaces, and that is a separate interface altogether. If you look at, for example, the booking interface, okay, this is a bit more extensive. So if you look at booking service facade, for example, you'll see the same sort of thing going on. In fact, this is just an interface. The implementation is here. Okay, so this is again just a facade, and as you can see, it's using a number of different things, repositories, services, and as you can see, booking service is actually the domain service that we talked about before. Okay, and it basically responds to different use cases in your application. So booking new cargo, loading a cargo for routing, assigning a cargo to a route, changing destination, and this is, by the way, functionality in the UI, changing deadline, listing all cargoes. These are all high-level objects, high-level use cases, and they all and as you'll see, they're relatively short, each of these methods, because all of the work is actually delegated to a lower layer. Okay, so that is the interface layer there. Next, let's move on to the application layer. Okay, so there's really one application layer object that is most important. The other parts of the interface actually are skipping the application tier, which, by the way, you can do that. The application tier is not mandatory, right? You can directly interface with the repository or domain layer from the interface layer if you like. The application tier is more of an intermediary. So as you can see, there is an implementation of it, and that is the default booking service. So we talked about that already, and this is definitely a application tier object. So again, it's modeling those high-level business cases, booking new cargo, requesting possible routes for cargo, assigning a cargo to a repository, and this is a stateless session bean. Let me increase the font a little bit more, I think. This is a stateless session bean, and these are all basically the transaction boundaries. So if you take a look at book new cargo, for example, it is creating a bunch of domain objects. It is invoking the repositories, and actually it is making a business call invocation in here. We're just not seeing it. We'll see it when we look at the domain layer. Same thing for, let's say, assigning route to a cargo. So we're looking up the cargo. We're not implementing the assignment in here because that's business logic. That is actually implemented as behavior of the cargo object, which is a domain entity, and actually an aggregate. And then we're storing it out in the repository. So this is the typical implementation of the application layer. And then you have the infrastructure layer, and you'll see again there's implementations of some of those. So there's CDI, there's logging, there is messaging, and so on. So logging, as you can see, we have a logger producer here. This is infrastructure level concerns. Right? This is why it warrants sort of its own object. Similarly, for all of the repositories, so if you look at the persistence, there's a number of repositories here. We'll take a look at the cargo repository, for example. This is where all the JPA entity manager code actually is. It happens to be a CDI applications code bean. So I'm injecting the entity manager here and taking care of the finders and find all method, the store and the update, delete, all of that is actually implemented within this repository. Okay, and finally, let's take a look at the domain layer, the most important portion in domain-driven design. So as you can see, it is broken down into the model and service portions. So I do have a domain service, as we talked about. Routing is a service here. So there is a routing service implementation, and that is part of the infrastructure tier as well. But routing service is an example of a domain service, right? So as you can see, it just has one verb, right? It's modeling. Just fetch me, given a particular route specification, so source, destination, and deadline, what are the routes that match this particular thing? That is an important behavior, and it's a top-level domain concept. So in the model, you'll see that there is that's broken down into different parts also. So this is corresponding to the top-level aggregates in my application. So cargo obviously is an important one. Handling is another important one. Location is another important one. Voyage is another important one. And these roughly correspond to key entities or aggregate routes. So for example, in the cargo aggregate, I have the cargo entity, and that is actually an aggregate route. And that aggregate route actually uses a number of other entities and value objects. So delivery, handling, itinerary, leg, all of these are also entities themselves, but they are the main aggregate route here is cargo. Okay, so if you look at the cargo object, it is an entity. Okay, it's a JPA entity. It has an ID. Here's the ID. It has a number of state, and each of these states are actually either primitives or embeddable objects, or in some cases relationships to other entities. So there's a tracking ID. That's the ID. Location is another another entity actually. So we do have a many-to-one relationship. So this is the origin. Similarly, we have things like delivery and route specification and the like. And you'll see there's business logic built into here. So here's, for example, specifying a new route. So in here, there'll be things like delivery, update on routing. And this is where all of the business logic actually resides. So let's take a look at one of these ones that are not aggregate routes. Right? So here's another entity and similar thing going on here. And I believe there's some business logic in here as well. No, not much. Not much. Not every single entity will have behavior. Some of them really are just state handlers. But if you look at delivery, for example, delivery should be an embeddable. Yeah, it is an embeddable. Okay, and it actually has a number of important bits of business logic built into it. So there will be things like calculating ETAs and the like. There's a non-trivial bit of business logic typically going on in the delivery object that you can take a look at. So that is basically a quick look at how Cargo Tracker implements these DDD concepts. Let me just move on, and we don't have a lot of time left. We have just about 3 minutes, so let me finish up. So as you can see, and you will see when you begin to investigate the Cargo Tracker application, Jakarta EE actually fits DDD very well. And if you really begin to look at DDD, it's a very nice, clean way of implementing enterprise applications. In fact, nowadays, finally, things are coming to some kind of sense, and people are talking about things like strategic monoliths and modular monoliths. And in fact, that is what the Cargo Tracker application actually is. It's a modular monolith. If you wanted to, you could break Cargo Tracker up into many smaller pieces, but there won't be much of a value proposition to be doing that. But all of the architecture and modularity is already there because of the way DDD is structured. So you almost get modularity for free, if you will, if you take a certain approach of modeling domain-driven design between layering as well as the concept of aggregate routes. It all works out fairly nicely. So hopefully, Cargo Tracker is a great place where you can get started with all of this. I do have some resources for you. All of these are listed in the resources section of the documentation of the Cargo Tracker website also. So of course, there's the Cargo Tracker website itself, and then there's some good resources to get started with domain-driven design. I highly recommend the one-pager by DZone. I think it's a very good one. There's a nice ref card on DDD. There's also a very nice mini book that InfoQ has on DDD. It's a very small, thin book. For people just beginning DDD, I almost reference it as like a tabletop book, if you will. It's like less than 100 pages. It's a real thin book on DDD. And of course, if you want to learn more about Jakarta EE, there's a Jakarta EE tutorial and Jakarta EE examples. Cargo Tracker is supposed to be a sort of a complementary resource to those things. But the last thing I want to do before I finish off here is also invite you to not just use Cargo Tracker, but also contribute to it. So there is a roadmap and a list of issues that we are working on. And all of those issues are tagged with the issues that you can help with are tagged with help wanted and good first issue. And there's also, by the way, a discussion alias for Cargo Tracker. So if you want to begin contributing or you have questions or concerns, aside from reaching out to me, you could always make use of that. So anyway, I think we are at time now. I'll do a last check to see if there's any questions. If not, I really appreciate your time. I hope this was useful.
Yes, I do see 3 questions here. So there's one in the Ask a Questions tab. Is WebSocket used in Cargo Tracker?
Okay, so let me take a look here at the questions. I'll start with the Q&A thing. And actually, let me stop sharing. I don't think I need to share anymore. So let me stop that. Okay, so let's take a look at the questions. Is WebSocket used in Cargo Tracker? WebSocket used to be used in Cargo Tracker. We don't use it anymore. The reason we don't use it anymore is because we didn't have the use case. And it turns out that the live map that you saw that I briefly demoed that used to be implemented using WebSocket, but it turns out that we can get away with just implementing it using SSC. So we got rid of the WebSocket use case, but we do have SSC or server set events demoed, with the live map. If you can think of a use case, a legitimate one for WebSocket, there's no reason why we couldn't put WebSocket back in. If you want to take a look at WebSocket, the old version of the application, so the Java EE5 version of it, the Java EE6 version of it, and we have all of the old versions also in the project. So the Java EE6 version does have WebSocket in it. If you want to take a look at how that looks like, but the current version, the Java EE8 version, does not. It's simply using SSC for that same use case. Okay, what would happen to the application if WS redesigned as microservices? If it was redesigned as microservices, you can do that. Basically, what you would wind up doing is you would break up every single one of the interfaces layers as its own deployable var or a fat jar, if you will. If you really wanted to go even further, you could deploy each of the aggregate roots as their own microservice and so on. Right? It just depends on how micro you want to get with microservices. But the same principles of domain-driven design would actually apply. So you would basically treat each microservice as its own domain context, which we didn't really talk about too much. Can we get a copy of the presentation? So it's already there, actually. So I've posted it towards the beginning. Let me post it again. So yeah, you can definitely get a PDF copy of the presentation for sure. Thank you, Jeffrey, for posting the slides. But if you really wanted the source, the PowerPoint for it, yeah, just reach out to me or post on the mailing list, and I'll share that with you. It's no problem. You can have at it. Okay, so if there's no more questions, I guess we'll wrap up today.
Yeah, so thank you for that excellent presentation today, Reza. Just a reminder, if anyone else has any questions, you can pop them in the chat while I just wrap up here. So our next Jakarta Tech Talk happens February 1st, and it will be on the topic of migrating a monolith to cloud native. So you can register for that session using the link that I will post in the chat. As well, we're looking to book more Jakarta Tech Talks throughout 2022. So if you're interested in presenting, you can feel free to fill out the form, which I will also put in the chat now. So you should be able to see both of those. And I don't see any other questions. So if that is it, then I would just like to thank Reza for your presentation today, as well as everyone who could attend. I hope everyone has a great rest of your day.
Great. See you guys later.
Thank you.
Bye.